My dear viewers, welcome to Future Knowledge Bank. And yesterday it was the 100th episode, and today is the 101 new beginning with the tough important chapter similar triangles. In the state syllabus we call triangles, we call in CBSE pattern. Same syllabus and same sums, we call the triangle is a heading for CBSE students, and same pattern similar triangles is a heading for the Telangana board system. So this is a very good chapter, and many students will feel that one this is a strugglesome system and a strugglesome sums, but I want to make you people to be the most easiest and easy to go through, and all kinds of the troubles I want to make you do very thoroughly here. And actually there are all the 8.1 exercise sums, 8.2 exercise sums, 8.3 exercise sums, 8.4 exercise sums, depends upon the basic proportionality theorem, also called as a Thales theorem, because the Thales scientist is responsible for the same. And the second one is converse of BPT theorem, and these two theorems actually explanation also, derivation also is important. So converse of BPT and BPT theorem I want to express clearly, and today I want to make this similar triangles into four parts. In the first part is BPT theorem come 8.1 exercise sums. In the second part, converse of BPT theorem with the 8.2 exercise sums, and the third part 8.3 with the Pythagoras theorem, and the fourth part with 8.4 with 8.6 theorem. That is areas of the similar triangles is equals to the square of the corresponding sides. One important formula is there in 8.6 theorem. So these four theorems, if you are thoroughly, that means Pythagoras theorem, 8.6 theorem, Thales theorem, and converse of BPT basic proportionality theorem. These four theorems will give you complete boost of this similar triangles. No hard, you can be feel completely easy. Now we'll go for first of all the main sheet anchor role, which is playing very important sheet anchor role, means that is a basic proportionality theorem, also called as Thales theorem. Here, try to understand. Actually, in your question, they won't ask you explain the basic proportionality theorem. Just they will give the theorem here. Heading they won't give. So that is the main strategy. You feel that one, they will ask heading. They won't give heading. They will give this one. What is that? If a line is drawn parallel to one side of a triangle, I will repeat. If a line is drawn parallel to one side of a triangle, that means a DA line is drawn parallel to one side. One side means it is a BC. BC is the one side, and DE is a parallel. But the same DE line is intersecting other two sides, AB and AC. This AB is getting intersected at the point D. At the point D, and AC is intersecting at the point E. Side of a triangle, yes, DE is drawn parallel to BC of the triangle, and other two sides AB in the distinct points, they are intersecting other two sides in distinct point, means AB is intersecting at a distinct point D, and AC is intersecting at the distinct point E. Then other two sides are divided. These two sides are getting divided with the help of D and E points in the same ratio. That means we have to prove that one. What we have to prove? RTP here. What is RTP? Required to prove. This main theorem's main thing is required to prove. What is required to prove? AD by DB is equals to AE by EC. This is our target in this basic proportionality theorem. So in this target purpose, actually in the question purpose, what kind of the diagram you have to apply? This is the question point of view diagram ABC, and he told one line is parallel. This much of diagram only we can draw with the help of the theorem, and remaining diagram you can see in the chart. That is our own construction to prove this one. This is our construction. Now that purpose, we have to go for the second step is construction. Here, what you have to construct? Join BE and we are going to join BE and CD. And again, you are joining DM, and that means here further what you are going to do? After joining, we are draw here DM perpendicular to AC, EN perpendicular to AB. Once again I will repeat, we have to draw DM is perpendicular to AC and EN is perpendicular to AB. That means perpendicular whenever the dialogue has come, you be that one, it is 90 degrees. Then only we call it a perpendicular. If it is not 90 degrees, exactly not 90 degrees, you shouldn't call the perpendicular dialogue. So, draw DEM perpendicular. This is a symbol. Perpendicular to AC and EN is perpendicular to AB. So now this construction is over. What actually now prove? We have to prove this. What you have to prove is and now we have to compare. This is the chapter name is what I told you, similar triangles. Now we have to work out each and every sum in the 4 chapters or 4 exercises of similar triangles. Is every sum of this 8.1, 8.2, 8.3 and 8.4, you have to compare two triangles. We have to take in the similarity of the two triangles over here. So now first of all, I am going to take the 2 triangles here, A, D, E, one triangle with the base AD. Once again I will repeat, first triangle I am taking A, D, E with the base as, I am considering base as AD. For this base, one height is there, one altitude is there. That altitude is EN. EN is a altitude for the triangle ADE. What is the base of this one? Actually, ADE means people will think that D is a base. People will think that D is a base. No, we have to consider AD is a base and height of this triangle is EN. EN is the altitude or height of the triangle. So now, according to the that one, first area of the triangle ADE. Area of the triangle ADE, a line EN is perpendicular to AB. Now, area of the triangle ADE is equals to half into base into height. Half into base into height. Here, half we know very well, that is a numerical. Base is here AD. AD is a base. AD into EN. EN is the height of the triangle. Now I got area of the first triangle. Comes to the point of the area of the second triangle. Area of the second triangle is equals to, I am taking the comparing AD triangle with the base is AD and the height is EN. Now another triangle is BDE. This BD triangle, base is BD. Base is, you can say DB is a base. DB is a base. DB is the base of the triangle. Triangle name is BDE. DB is the base. And where is the height you will confuse? For this triangle purpose, where is the height you will confuse? Height is EN only. EN is the height for the BD triangle also. You may confuse BD triangle is here, EN is here. Don't need to confuse. Why? Because EN is a perpendicular line for total AB. EN is a perpendicular line for total AB. So the height of the BD triangle also EN only. The height of the BD triangle also EN only, because EN is perpendicular line for total AB, not AD, not just AD. It's a total AB. What is height for total AB means EN. So BD triangle purpose, AD triangle purpose, EN only. Now see, the area of the triangle BDE is equals to half into, what is the base here? DB. Height is EN. I told you just now. EN is common height for AD and DB. Again, this is two triangles we got finished, and come to the part of another two triangles here. Just now, we are taking the ratio of these two triangles. What are the two triangles? Because in the similar triangles, always you have to compare the two triangles I told you. I am taking the ratio of these two triangles. That means area of the triangle ADE by area of the triangle BDE. So this purpose here, half into AD into EN by half into DB into EN. Here EN cancel, half of cancel. What will be left here? AD divided by DB. This is the, you consider equation 1. We got one ratio here, AD by DB we got. Now we have to get another ratio. I think you got it. You check once here. Two triangles are taken. The triangle ADE, one triangle with the base is AD and the height is EN, and another triangle is BDE. The base is what you call DB and height is EN. EN is a common height for both the triangles. See, because EN is a perpendicular line for total AB, not AD. Another two triangle I am taking in the triangle ADE. In the triangle ADE, what is the another triangle ADE? Already you are confusing, I think so. ADE already taken in the first time, but now I am taking ADE with the base is AE. Now AE is the base for that one. So, and height of this triangle is DM. DM is the height of the triangle, what you call ADE. In the ADE, so according to that one, area of the triangle ADE is equals to half into, what is the base here? AE is the base and height is DM. DM is the height. And another triangle CDE. Once again, CDE is the second triangle. I am comparing with the AD triangle. AD, the second AD triangle base is AE. First AD triangle base is AD. First AD triangle base is AD, but the second AD triangle base is AE. And height of the second AD triangle is DM. And height of the CDE triangle also DM. Why? Because DM is a perpendicular line for the total AC, not total only AE. So that is the reason area of the triangle CDE is equals to half into EC into DM. So I am taking the ratio of this one. Area of the triangle. Area of the triangle ADE and area of the triangle CDE. So what is the area of the triangle here? Half into AE into DM by half into EC into DM. Here, because of the same height, half of cancel, DM cancel. What is left over here? AE and EC. This is the equation 2. In the first ratio, what I got? AD by DB. And second ratio, what I got? AE by EC. But here, how can you say these both are equal? Here one statement we need. We got the two ratios. What is asking in the BPT theorem? AD by DB we got, AE by EC we got. But how can you say these are both are equal? Means what is the evidence means? You can see here BDE triangle, this BDE triangle and the CDE triangle both are constructed on the same base DE. Once again I will repeat, the BDE triangle and CDE triangle, both the triangles are constructed on the same base DE. And if both the triangles are similar, this ratio is also similar. You have a final statement what you have to write. The triangles BDE and CDE are constructed on same base, hence they are equal, same base DE. Therefore this ratio is okay for that one. This is what we call basic proportionality theorem or Thales theorem. Now we'll go for the sums in the 8.1 exercise. Little 1 minute gap. Now come to the point in 8.1. Most important three sums I am going to explain in that one. First one is you can see here one diagram is there which is having the two triangles. One triangle is A B C. Here one triangle you can see in the figure. A B C is one triangle, and you imagine just now you finished the basic proportionality theorem. In this case, here in this triangle ABC, BC is the base. Here BC is the base and LM is the parallel line to the base. That means here basic proportionality theorem is applicable. Basic proportionality theorem is applicable here. So if this LM is parallel to BC, immediately AM by MB and AL by LC, this ratio is going to be resulted. So now, and you can see here what is saying in the given figure, LM is parallel to BC side and LN is parallel to CD side. That means another triangle is ACD. This triangle is CD is the base and LN is the situation. So finally what is asking? Is asking that one AM by AB. You can see here AM by AB. That means what you call small part by that big part totally and AN by AD. How to get this ratio? To get this ratio, certain calculation is there. That calculation I am explaining by applying the basic proportionality theorem and so on. So first of all, we will go for the ratio. According in the triangle, A B C. Here LM is parallel to BC. You can see there clearly LM is parallel to BC. Okay, then according to basic proportionality theorem, here AM by MB equal to AL by LC. This is the ratio we will get. If this is LM is parallel to BC means if it is LM is parallel to BC, automatically AM by MB or and AL by LC. Very simple to see. Now here we got the ratio. Now here don't confuse and observe clearly while I am explaining. Here what I have to do, this ratio we have to do one certain short difference. We have to invert 10. That means you have to make the denominator into numerator, numerator into denominator. MB by AM. MB by AM is equals to LC by AL. That means we did reciprocal, that we call invertendo. We call it as invertendo. Okay, we did invertendo. Later on, thereafter, we are not getting stopped. Further, one more situation we are doing here. MB by AM plus 1. I am adding 1 on the either side. I am adding 1 on the either side. Plus 1. After taking the plus 1 adding, because it is looking like a fractional formation, I have to go for LCM on the both the sides. Here LCM is AM. So here AM by AM is 1. 1 into MB, MB. Similarly, here AM by 1, AM into 1, AM. I got here what after the LCM I got here. MB plus AM by AM. Here which is equals to AL is a LCM. AL by AL 1 into LC, LC. And here AL by 1, here AL I got. And then what I am going to get here? Here AM plus MB plus AM, MB plus AM. If you are adding these two, what is the result I am getting here? I am getting the result AB. AB by AM is equals to LC plus AL. If I am adding these two fractions, I am getting AC. AC by AL. Now I got what I did. I took the ratio. I did invertendo. Now I did the here componendo. Also I have to do. This is adding one on the either side is called componendo. Componendo. Component is completed. After component I got one ratio. That ratio here I did invertendo. No? Now I have to go for invertendo base. This means AM by AB is equals to AL by AC. This is the equation 1. To get the equation, what are the steps you have to go through? You see, first you have to take the ratio. Then you have to go for invertendo. That means reciprocals you have to do. After getting reciprocals, component we have to do. That means we are adding one on the either side and take the LCM. After LCM we got certain ratio. That certain ratio because we did here invertendo, no? We have to do again invertendo here. Invertendo, componendo, invertendo. So here invertendo, then we componendo, then invertendo, then ratio is 1. Now come to the point here. I am going for another another triangle. What is another triangle? ACD. In the triangle ACD, LN is parallel to CD. Here already is given LN or LN is parallel to CD here. If it is that is parallel to CD means automatically according to basic proportionality theorem, what ratio will get? AN by ND, AL by LC. Once again, AN by ND, AL by LC. Why? Because here CD is the base and LN is the line which is parallel to one side and intersecting other two sides. So we will get the basic proportionality ratio AN by ND is equals to AL by LC. This one we know very well. What you have to do? Same steps will proceed. We got the ratio, we got the ratio. We need invertendo. Here also we will do invertendo, that is ND. ND by AN is equals to LC by AL. And we are going for component here. ND by, this is invertendo, and invertendo is over. We are going for componendo now. Plus 1 we have to add on the either side. Plus 1 on the either side. Now we are taking the, after doing invertendo, we are taking LCM for this one. AN is the LCM and we will get ND plus AN here. ND plus AN. Again here is a AC. AC means LC plus AC will get here. So after LCM, ND plus AN. ND plus AN if you are adding, we will get AD. AD we got. AD by what is the denominator? AN is equals to LC plus AC means LC plus AL. Here LC plus AL will get AC. Now We'll go for the component here. After component, nd plus nd plus an will get ad, and lc plus al will get ac. Now what we got ratio ad by an is equals to ac by al. This already once we inverted. That purpose we are going once again invert and we will do al by an by ad is equals to here AC by AL by AC, and this is the invertendo is over. This is the equation 2 invertendo, and this is the equation 2. And now we got the two equations very clearly here, and then what we are going to do, we are equating both the equation 1 and this is the equation 1. Keep it in mind. This is the equation 2. If we are equating these two, we should get this final equation over here. Now just check once here whether we get the final equation or not. One equation I am keeping for your reference point of view. Here, what is the final equation here? First equation, AM by AB is equals to AL by AC. This is the equation number 1. Dividing. See equation number 2. AN by AD is equals to AL by AC. Now here, whenever equating AL by AC both are cancelled. What is left here? AM by AB is equals to AN by AD. Whatever we want, we got here. So here, only two things you have to remember in this. One triangle you have to take. You have to take the ratio. After the taking ratio, you should go for the first step is invertendo. Then second step is componendo. After componendo, you take LCM. After completing the LCM, you again invertendo. Why? Because earlier you invertendo you did. Then whatever the ratio you are getting, that is equation number 1. In the second triangle ACB also, you take one ratio according to basic proportionality theorem that you make first of all invertendo, then you add one on the either side, it's a componendo, then finally you go for one more thing else, what I call invertendo, and whatever the equation you are getting equation 2. And equation 1 and 2, if you are what I call equating, we are getting the whatever the final ratio we should get AM by AP is equals to AN by ND. And we And here the another important sum you can see the sum number I think it is a 6. Sum number 6 in 8.1 exercise is the most important one, and it is very easy also. Here one big triangle are taking, that is a P. Here PQR, one triangle is a big triangle PQR. In this triangle, two triangles you can find out. I already told you what we call comparison of two triangles. In every sum we are going to be possible. Here, what is the question? Actually, what is the data is given in the question? What is asking that we need over here? Here, see, in the given figure, this is a figure PQR, and here D is given here. The term EF is one line is given. EF one straight line is given, and QR is given. EF is now is asking DE. See, this is the DE. This DE line is parallel to OQ. That means here two triangles are there. One triangle is POQ. One triangle is, once again I will repeat, one triangle is POQ. Another triangle is POR. To the triangle POQ, I will say here, in the triangle POQ. In the triangle POQ, the line DE is parallel to OQ. That means this line DE is parallel to OQ. This line. Triangle is POQ. Triangle is POQ. DE is a line which is parallel to OQ. And the E is intersecting the PQ, and the D is intersecting the PO. So now here, because if it is D is a parallel to OQ, automatically we can easily apply the basic proportion theorem. According to BPT theorem, here what we call PE is PE by EQ. PE by EQ is equals to PD by DO. PD by DO. This is the equation 1 we got. Now we'll go for another triangle here, POR. In this triangle, DF is a parallel line to the OR base. OR is a base, DF is a parallel line to the base. And we are getting the here also one more ratio. What is the ratio? PF by FR. PF by FR. PD by DO. Once again, PF by FR. PD by DO. So now here, according to in that what I am saying, in the triangle POR, the line DF is already given. DF is parallel to OR. DF is parallel to OR, and then according to basic proportionality theorem, here PF by FR, PF by FR, here PF by FR and PD by DO is equals to PD by DO. Now I got the second equation also. Now if I both after equating these both, now we have what is our main function? Equating 1 and 2. Equating 1 and 2. Equating 1 and 2 equations. First equation is what? PE. Clearly observe this one. PE by EQ. That is equation number 1 equal to PD by DO. This is the first equation divided by second equation PF by FR is equals to PD by DO. Now here you see PD by DO we having, both are going to be get cancelled. What is left? Final ratio what you are getting here? PE by EQ. Observe this final ratio. That is we will give the perfect answer for us. PF by FR. Here now by this ratio, how this answer we can say? Show that EF is parallel to QR. Now with the help of this ratio, we have to show that one. EF is parallel to QR. EF is parallel to QR. Now how means? You can see here PE by EQ. This is the first ratio. PE by EQ first ratio, and PF by FR is the second ratio. If this ratio are equal, if the result we got, the ratio are equal. If the ratio is equal means 100% the EF is parallel to QR. If this ratio is equal, which ratio? PE by EQ and PF by FR. This ratio whenever we got equal, that occasion EF is 100% parallel to QR. That is only is asking to prove us. According to the converse of BPT theorem, when the ratio we got and the line, the parallel line is going to be get parallel to the other side. Now he is asking, show that one EF is parallel to QR. Yes, exactly. EF is parallel to QR. How? Because we got the equal ratio here. What ratio? PF by EQ, PF by FR. This is the way. Seventh sum also similar method is having in this 8.1. That purpose I am not giving seventh one. I will give the eighth sum in the next part. Thank you for watching.